All right, so if you're following along with the PowerPoint, this is 5.4 for trig, and it's 4.2 for pre-cal. Oh, full of mistakes today. And this is, now that we saw how the unit circle works, how those numbers come about, we're going to see how to actually use the unit circle and what to do with it. So back in a previous course, like geometry and algebra 2, you probably started to learn the acronym SOHCAHTOA. You guys remember that? Okay, so that is heavily involved here. You're going to see there's even a section we're going to learn doing SOHCAHTOA, and you're going to think that this is cake, hopefully, okay? So in trigonometry, we have 6 main functions. You guys have been learning functions for a while, like x squared is a parabola, log, you know, e to the x, those are exponential functions. Now we're learning trigonometric functions, which are these 6. Let me go over what their names are, okay? This is not sin, this is sine. These are abbreviations, okay? So this is sine, and then remember theta was like x. It's where we're going to be plugging our numbers into. So you might hear me say sine sometimes, and you might hear me say sine of x or sine of theta, okay? It just means that that's where we're plugging in our values, okay? So we have sine, cosine, tangent. You might be used to those. And then we have their reciprocals, which is cosecant, secant, and cotangent. I wrote them specifically so that their reciprocals are next to each other, okay? Now, what in the world do these 6 trig functions have to do with the unit circle? Well, on your unit circle, I kept talking to you guys about ordered pairs. The ordered pairs x comma y represent the values for the cosine and then the sine. There's a beautiful thing in math that they've always kept things in alphabetical order. So just like x comes before y in the alphabet, c comes before s. That's how you're going to hopefully remember that the x value is your cosine and the y value is your sine. Make sense so far? Okay. Now, so I told you that these 3 are going to be the reciprocal of those 3. Another time earlier in math, you might have heard the word reciprocal is when you were dividing fractions and your teacher might have told you keep, change, flip. You guys remember that? So reciprocal literally means to flip, okay? So the way I find cosecant is I flip-flop whatever the answer was of sine. So if my answer for sine was 2 over 3, what do you think my answer for cosecant is going to be? 3 over 2. And the same thing works from secant to cosine and from cotangent to tangent. Okay? So if I have one of their answers and I need the other, I just flip them. So the way they write this as a formula is that sine of theta is equivalent to 1 over cosecant. Cosine is equal to 1 over secant, and tangent is equal to 1 over cotangent. Okay? The same can be said in reverse. It's not necessarily more for you to memorize, but we could also say that cosecant is equal to 1 over sine. Secant is equal to, help me out with this one, 1 over cosine. This is how you'll see the formulas written in your book, okay? And cotangent of theta is equal to 1 over tangent. So if you need one of them, you just flip the other, okay? These are called the reciprocal identities. Okay? Now, if I give you a specific location on the unit circle to look at, with the ordered pair, you can quickly see that you have cosine and sine. And flipping those 2, I have cosecant and secant. What I have next to show you is how to find tangent and cotangent. Okay? Tangent is the ratio between sine and cosine. That's where that trig function came from, okay? So tangent is equal to sine divided by cosine. And if cotangent is the flip-flop of tangent, right? Cotangent is the flip-flop of tangent. What do you think my division is going to be for cotangent? Cosine over sine. Does that make sense? So you have your reciprocal identities, how they flip-flop, and then you have what's called your quotient identities, okay? The ratio between sines and cosines. So hopefully now I can show you one spot on the unit circle, and you can find all 6 trig functions. That would be the goal before we go home today, okay? Any questions up to here? Okay. And we look at an example. Let's look at something simple. Let's look at the first spot on our unit circle. At 30 degrees, also known as pi over 6. What is my ordered pair? You guys can help me out here? Beautiful. Radical 3 over 2, comma, 1 over 2. Okay, I know this from my unit circle. I look at that first spot, which has 30 degrees and pi over 6, and I know my ordered pair is radical 3 over 2 and 1 over 2. So your job right now is going to be to find all 6 of the trig functions. Okay? Right away, because we know the ordered pair from unit circle, we have our x and our y, so we already have 2 out of the 6 given to us. Okay? So I know that cosine of the theta that they're specifically talking about here is 30 degrees and pi over 6. So this is cosine of pi over 6 equals my first spot, which is radical 3 over 2. Easy? Next of the 6 is sine of pi over 6. This again should be easy because sine is always the y value. So my answer here is 1/2. And just like that, you have 2 out of the 6. Let's move on to find tangent. The rule for tangent was to divide the sine by the cosine. Now right here, I see that, sine is written on top of cosine. Being that we're working with fractions, I'm going to encourage you guys to write them horizontally so we can easily see the keep, change, flip when I'm dividing, okay? So tangent is sine is 1/2, divided by cosine, which is radical 3 over 2. Good till there? Okay. So then we have to keep, change, flip, because we're dividing fractions. So 1/2 times 2 over radical 3. A reminder that any time you're in multiplication, you can reduce any numerator with any denominator, okay? So you could cancel these 2's right away. If you don't see that yet, you can go straight to 2 over 2 radical 3 and then reduce them. Okay? Now, I don't know how many of you remember I believe it was Algebra 2 when you learned this, about rationalizing denominators. In Algebra 2, you learned that it's not the neatest format to keep a radical in the denominator. Not by its inverse, but by itself, top and bottom. I don't want to change its value, but good. You're going to multiply this whole fraction by that radical 3. Radical 3 over radical 3. 1 times radical 3 is radical 3. What's radical 3 times radical 3? Radical 9, which cleans back up to 3. Anytime you multiply a radical by itself, it will cancel out the radicals and you're just left with that number. Okay? And with that, we have our tangent answer. Okay? How are we doing up to here? Now, we have to find the other 3. You can go in whatever order you want. But if you do find sine, cosine, and tangent first, it should make your life easier because all I have to do for my next 3 answers is start flipping things. Okay? You do not have to use the division for cotangent. If you've already found tangent, then you can just flip tangent. Does that make sense? If you haven't found tangent, then you're going to have to do this. Okay? So, we have tangent, cosine, and sine. Let's start in order. Let's do the flip-flop of cosine. Flip-flop of cosine is secant. So secant of pi over 6. What happens when I flip cosine? All right, I get 2 over radical 3 and I have a radical in the denominator. So I do have to rationalize again. Multiply by radical 3 over radical 3. And my answer is 2 radical 3 over 3. Bless you. Next, I'm going to do the flip-flop of sine. Okay? The inverse function of sine is cosecant. This one's nice and easy. What do I get when I flip sine? Beautiful. Just 2. If some of the work that I'm doing, guys, feels redundant to you, like literally writing 2 over 1, you don't have to do that. I'm just taking it baby steps, okay? And the last one that I need to find is cotangent of pi over 6. I want all eyes up on the board for a second. Okay? I told you that cotangent is flipping tangent. If I flip my final answer of tangent, what's going to happen? I'm going to have the radical on the bottom, and I'm going to have to rationalize again, which won't be incorrect. It'll just be a little time-consuming. What was the first answer that I got from tangent? When I finished the division. 1 over radical 3. Whenever you had to rationalize and you're going to be flip-flopping, always check back to what you had here. Because if I flip-flop this, what do I get? Radical 3 over 1, which is just radical 3. And I eliminate having to rationalize again. Again, you won't be wrong if you go through that process. It'll just take a little longer. Okay? So you just learned that in trigonometry there are 6 trig functions. They come from the values in the unit circle. And you learn the relationship between the 6 of them and how to be able to get them just from that single ordered pair from the unit circle. How are we feeling with this? We're on slide 6. They give us a point, 1/2, comma, radical 3 over 2. But they don't tell you what the theta is. Looking at your unit circle, what theta are they talking about? Or you can remember with your fingers. When do you have a 1 and then 3 on your fingers? At pi over 3. So they're talking about pi over 3, and if you're looking at your unit circle, this could also be called 60 degrees. Okay? So they want you to take a moment and find the 6 trig functions for that location. I want you to try and get it started on your own, and then I'm going to help you finish it. All right. So hopefully you've had some time to try this on your own. Cosine is my x value. So cosine is 1/2. And sine is my y value, which is radical 3 over 2. Okay? Now, I wrote them next to each other according to who's their flip-flop, so I can go straight to saying that if cosine is 1 over 2, secant is flipping that, which is 2 over 1, which is just 2. And cosecant is flipping sine, which is 2 over radical 3. Rationalize that by multiplying it by radical 3 over radical 3. And I have 2 radical 3 over 3. And just like that, just by looking at that ordered pair and starting to flip, I already have 4 of my 6 answers. Raise your hand if you were confident about those 4. Nice. All right, tangent is sine divided by cosine. So I'm going to write horizontally my sine divided by my cosine. I'm dividing fractions, so I'm going to multiply by the reciprocal. I'm going to keep the first one, change the multiplication, and flip. Okay? My 2's cancel, and I'm left with radical 3 over 1, which is just radical 3. Okay? Raise your hand if you got to the tangent on your own. Nice. And cotangent is to flip tangent. So when we solved for tangent, we did not have to rationalize. Okay, so there isn't like a previous answer that was unrationalized. Radical 3 is like saying radical 3 over 1. So when I flip that to get cotangent, I have 1 over radical 3. I have a radical in the denominator, which, by the way, does not make it an incorrect answer. It's just not a clean answer. So if you're looking at the back of the book to check your answers when you do homework or like on a multiple choice on a quiz or test, it will be clean, okay? So I need to rationalize this. And I'm left with radical 3 over 3.